Alright, so we are graphing quadratic equations using a table of values. Um, this is review from 4.1 and 4.2. Remember, graphing using a table of values can be a long process, long and tedious, but it's a good skill to have because it always works. So the way I like to do graphing by table of values is I like to choose, so the first column, I should say, um, the first column of a table of values is for the x-coordinate. And for this column, you could choose any number you wish. And in most cases, well, you could choose any number you wish. But sometimes it's good to choose x values that will get rid of the fractions for the y value. It doesn't apply in this case, but just keep that in mind. So I usually like starting off at 0, finding some positive points like 1, 2, and 3. I'm looking for a pattern in terms of whether or not there is a vertex. Remember, the vertex is the minimum or maximum y value, so we're going to be keeping our eye out for that. So that's the x column. The first column is the x coordinate. The second column is for substituting x into the equation in order to solve for y. So brackets really help in this case. So we're going to be looking at the equation y is equal to x squared plus 3. We're going to be putting brackets around it, around where the x terms are. So the bracket x squared, so we're going to be putting a bracket there and squaring it, plus 3, for example. And the y column is whatever you get in the second column. So in this case, it's going to be 0 squared plus 3, which is equal to 3, right? And the ordered pair is going to be the x value and the y value, and this is the point on your graph. So the x value in this case, in this row, I should say, is going to be 0 and 3. Okay, so let's continue. Let's go x equals to 1. And we're going to be plugging that in. We're going to be making brackets, first of all, around the x terms in the original equation. We're going to be subbing the x, whatever the x coordinate is, into the equation. So it's going to be 1 squared plus 3. So 1 squared is 1, plus 3 is 4. The ordered pair is going to be 1 and 4. And then we got x equals to 2. Then we got, going to be plugging that into the equation, so it's going to be 2 squared plus 3, which is 4 plus 3, which is equal to 7. So the ordered pair is 2 and 7. Let's do a couple of negative x values. So let's do negative 1. Let's see if there's a pattern. The general rule of thumb is find the vertex, find the minimum or maximum point. It should be somewhere in the middle, 5 to 7 points in total, and you'll be good to graph. You'll be good to graph the equation. Okay, so we're going to be plugging that into the equation. So negative 1 squared plus 3, right? It's going to be 4. The ordered pair is going to be negative 1 and 4. Do you notice a pattern? Yes. The minimum point is 3. Right? The vertex is at 3. Let's do one more negative point. Negative 2. We'll be plugging that into negative 2 squared plus 3. Negative 2 squared plus 3 is equal to 7. So the ordered pair is negative 2, 7. So now we have the ordered pairs. We can easily graph the equation. And there it is graphed for you already. I already graphed it out for you. Let me start all over again, actually. Let me start all over again for you to make it more clear. So our vertex, we found our vertex to be 0 and negative 3. So that's the point 0, negative 3 there. And then our point for x equals to 1 was 1 and 4. So let's find 1. Let's find 4. So we intersected that point. Our next point that we found was 2 and 7. 2 and 7 is right there. And then negative 1 and 4. And of course, you notice a pattern. Our axis of symmetry is a vertical line that crosses through the vertex. Vertex is 0 and 3. And the axis of symmetry mirrors the parabola. Correct? So we could look at it as if it mirrors 0.14, then the point negative 1 and 4 is going to be on the graph. But we already knew that because we did a table of values. So negative 1 and 4 was our entry. And then finally negative 2 and 7. So now we have all our points. Now we simply just connect the dots, make it into a nice U shape. And there we go. There's that graph for y is equal to x squared plus 3. Okay, I'll give you a moment to copy that down. How about if we're asked to graph the equation y is equal to negative 2x squared minus x plus 2 using a table of values. So again, we're going to have our x coordinates. We're going to have our y is equal to negative 2x squared minus x plus 2. Whatever we get, we're going to put over here in this y column, and then finally we're going to have our ordered pairs. So again, let's start off with x equals to 0. We're going to be putting brackets around the points where there's an x in the original equation, squared minus x plus 2. We're going to be substituting the 0 inside the bracket, so it's going to be 0. Oh, I should put a bracket around there. 0. I put 0 there as well. So it's going to be negative 2 times 0 minus 0 plus 2 is equal to 0 minus 0 plus 2, so it's going to be 0 and 2. Let's do x equals to 1 now. Again, we got negative 2. We're going to be putting a bracket around where the x terms are. So we're going to be substituting the 1. We're going to be putting it inside the bracket, so it's going to be negative 2 times 1 squared minus 1 plus 2. So negative 2 times 1 squared is just negative 2. Negative 2 minus 1 is equal to negative 3. Negative 3 plus 2 is equal to negative 1. Okay. Now let's do the same thing with x equals to 2. Negative 2 bracket squared minus bracket plus 2. We'll be subbing that in. It's going to be 2 squared minus 2 plus 2, which is going to be equal to negative 8. Okay, so let's not forget the order pair. Sorry, 1, negative 1, and 2, negative 8. Okay, let's do a couple of negative terms, and let's see if there's a pattern. Negative 1 is going to go inside of negative 2 brackets squared minus brackets plus 2. Putting that in there. That's going to be negative 2 plus 1 plus 2. It's going to be equal to, y is going to be equal to 1. So 1, sorry, negative 1 and 1 is going to be on the graph. Okay, so let's do negative 2. It's going to be negative 2 times negative 2 squared minus negative 2 plus 2. It's going to be equal to negative 4. So the ordered pair would be negative 2, negative 4. So do you notice a pattern here? So do we have enough points Absolutely. Because as you see, at when x is equal to 0, y is equal to 2, and then once you increase x, it's going to go down again. And also once you decrease x, the y is going to go down as well. So the vertex may not be exactly at x equals to 2, but we have enough points because we notice a pattern there. Okay, so let's therefore graph the equation then. Yeah, let's make that x equals to 1, and that's going to be x equals to 2. It's going to be equal x to negative 1, x equals to negative 2. 1, 2, 3, 4, negative 1, negative 2, negative 3, and negative 4. So our point was 0 and 2. That's our first point. And then 1 and negative 1. So it's going to be somewhere there. 2 and negative 8. So I have to extend my graph a little bit. That's okay. So it's going to be negative 5, negative 6, negative 7, negative 8. So 2 and negative 8 is the point on the graph. And then we got negative 1 and 1. Point there. And then negative 2 and negative 4. So we have enough points now for a graph. So we just connect the points now. So it's going to be like this now. So this is the graph of y is equal to negative 2x squared minus x plus 2. And we graph that by using a table of values.